x plus 1 to the power of 5 plus x minus 1 to the power of 5 equals 32 times x. You gotta solve it for x. Give it a real try, then continue watching. Good luck. What's up guys, this is Daily Math and we are going to do some algebra. We have a quintic equation, an equation of the 5th degree. So let's see how we can solve it. I'm going to expand these two expressions because we have, as you can see, x plus 1 and x minus 1, and these two are going to produce some opposite expressions that will cancel out, and we will be left with much simpler form of an equation. So let's just do it. How can we expand each of them? Let's write the formula here. A plus b to the power of 5 is a to the power of 5 plus 5 times a to the power of 4 times b, 10 times a cubed b squared, 10 times a squared b cubed, and now 5 times a b to the power of 4, and in the end b to the power of 5. Now let's apply this to the x plus 1 to the power of 5. We have x to the power of 5 plus 5 times x to the power of 4, 1, and then 10 times x cubed, 1 to the power of 2, which is 1. Now 10 times x squared, 1 to the power of 3, that's 1 again. And 5 times x, 1 to the power of 4, and in the end 1 to the power of 5. Now I'm going to write it again in a cleaner form. So it is x to the power of 5, 5 times x4, 10 times x cubed, 10 times x squared, and then 5x and 1. Alright then, now the same thing happens for the second expression, x minus 1 to the power of 5. Now we have x to the power of 5, 5 times x to the power of 4, this time negative 1, 10 times x to the power of 3, negative 1 squared, and then 10 times x squared, negative 1 cubed, and 5 times x, negative 1 to the power of 4, and negative 1 to the power of 5. Odd powers of negative 1 are going to be negative powers of 1, 3, and 5. This one, and also this one. Now let's write it again in a cleaner form. X minus 1 to the power of 5. Here we have x to the power of 5 minus 5 times x4 plus 10 times x cubed minus 10 times x squared. And then we have 5 times x minus 1. Now we're going to combine these two expressions and see what happens. On the left side it is x plus 1 to the power of 5 plus x minus 1 to the power of 5. And on the right side, as we have expected, negative ones cancel out the opposites. So this one cancels out this, and 10 times x squared, and then 1 and negative 1. So on the right side we have 2 times x to the power of 5, 20 times x cubed, and then 10 times x. Now let's replace the left side, x plus 1 to the power of 5, x minus 1 to the power of 5, with 32 times x as the question itself says. And here we factor 2, we have x to the power of 5, 10 times x cubed, and 5 times x. Divide both sides by 2. No rush, there's no competition here. We're just taking solid steps and enjoying the process. Now let's bring this one to the other side so that we have everything on one side. We have x to the power of 5, 10 times x cubed, and minus 11 times x. That's equal to 0. Alright, what else can we do? We have a common factor here. That's x, so we factor it. X times x to the power of 4, 10 times x squared minus 11. And now either of these expressions could be equal to 0. It could be the factor x, or the second expression, x to the power of 4 plus 10 times x squared minus 11. Now let's put a box around this one because it's a final answer. X could be equal to 0. We got 4 more to go, and we're gonna extract them from this Quintic equation here. We start by rewriting it like this as a form of a second degree equation because it's easier to solve. Now we should be able to rewrite it like this. Factor it, x squared plus something, and then x squared plus something else. The sum of these two numbers is 10, and the product is negative 11. Now let's do it in a mental way. What are these two numbers? I'm gonna say negative 1 and 11. Negative 1 times 11 is negative 11. Check. And negative 1 plus 11 is 10. Check. Now replacing in the equation, we have x squared minus 1 times x squared plus 11, and that's equal to 0. Now again, either of these two factors could be equal to 0. So it's either x squared minus 1 equals 0 or x squared plus 11 equals 0. For the first one, we have x squared equals 1, and that means x is 1 or negative 1. And for the second one, we have x squared equals negative 11, and that leads us to two complex answers. X is positive or negative square root of negative 11, and we can write it as positive or negative square root of 11 times I. And what is I? Square root of negative 1. And these are two complex answers for this equation. And let's write the other one that we found before. What was that? X is equal to 0. So we found 5 answers for this Quintic equation, and this is the end of this video. See you guys in the next one. Until then, take care.